Alright, so I just wanted to very quickly provide a video for forming net ionic equations and complete ionic equations. As I mentioned, I don't typically lecture on this because I'd rather you take the entire balanced chemical equation and be able to figure this stuff out rather than breaking it up into parts like this. I do find this to be a little basic, but since it is something that's covered in the text, and as I mentioned, I won't test you on it, but you may see a problem or two on the final. I just want to make sure that we're all prepared as we go forward with this. And so I want to take an example out of the homework, a reaction with beryllium chloride plus sodium hydroxide, which then undergoes a metathesis reaction or a precipitation reaction to generate beryllium hydroxide, which is not soluble in water. If you go to your precipitation chart, you'll find that hydroxides are typically water insoluble. Beryllium is not one of the exceptions, and so we would get this to be a solid. Everything else in this being aqueous. I won't bother to draw it, but just recognize that everything else is aqueous. The other product here is going to be sodium chloride, also aqueous. We have to balance this equation. If we go ahead and put a 2 in front of the sodium chloride, there are 2 chlorides over here in the beryllium chloride, so we need 2 chlorides. We've now generated 2 sodiums, and so we need to go ahead and throw a 2 in front of that sodium hydroxide as well. 2 hydroxides here, 2 hydroxides. So full balanced equation. Now, when we're drawing our complete ionic equation, what we're going to do is we're going to separate everything into ions except for the stuff that's a solid. So beryllium in this case is going to be beryllium 2 plus. You're going to have 2 chlorides, 2 Cl minus. You're going to have 2 sodiums, 2 sodium ions, and then also 2 hydroxide ions. This is going to then produce the beryllium hydroxide, which we can draw it as separate ions if you'd like, but still recognizing that it forms a solid. But if you want to do it according to by the book, beryllium hydroxide will be the solid. The other ions are what's known as spectator ions, not forming sodium chloride in solution because they are dissolved as sodium ion chloride. And so we'd have 2 sodiums and 2 chlorides. Now, this is the complete ionic equation. In order to draw the net ionic equation, we're going to cancel out the spectator ions and draw a simplified version of this. And so since we have 2 sodiums on either side of the equation, we can go ahead and cancel those out. Let me just change color here real quick. Go ahead and cancel those out. The sodiums cancel. The chlorides also cancel because they're on both sides of the equation. And we are left then with our net ionic equation, which would be beryllium 2 plus 2 hydroxides goes to beryllium hydroxide, which would be a solid. And so this is how we would draw our net ionic equation from this given process. As I said before, I would rather you just go ahead and use the balanced chemical equation to figure this out, rather than breaking it all up into this. It's pretty complex, I think, and unnecessarily complex. But if this helps you, I'm glad for it. And as always, if there are any questions, please let me know.